All right, hello everyone. Welcome to the June 21st, 2023 meeting of Sig-Auth. The recording is started. Let's take a look at the agenda. All right. All right, so a couple KMS things and then policy working group update. All right, do you want to kick us off, Mo?
Sure, I can. So the gist of these numbers are, I collected them at sort of various levels. Basically, the baseline is just a single API server process with resources not being encrypted, and then making a bunch of requests that and the requests basically successfully create Kubernetes secrets of larger and larger size until approximately the maximum size that we allow for a Kubernetes secret. And I conducted them sort of at two levels. One was through just regular REST semantics, so like basically the equivalent of kubectl calls. And the other one was from the semantics of the internal registry. So basically, I like skipped a lot of the layers around like authentication, authorization, and network stuff. So it's basically just hitting etcd through the Kubernetes layers, like so the low-level sort of storage implementation. And then I kind of compared them all between not having encryption, having encryption using KMS v2 as it stands today in master, so like 127 style, and then the proposed change with KMS v2 with the KDF-based approach. And basically, if I remember correctly, the number of the CPU time doesn't like meaningfully change at all in any of these. Granted, this was all done on my M1 Mac, so it might be washed out by the fact that my machine is very fast. So maybe in a cloud VM, you might see something a little slower. But otherwise, if you look at, I think that first one right there, you can kind of see the difference between having the KDF versus not. And I think basically if you zoom out far enough, it's on the order of like a 1% kind of deal in terms of like memory allocations, but otherwise it's not a overall big impact. However, if you zoom in closely enough and are like comparing somewhat synthetic benchmarks, KMS is relatively expensive overall, like in comparison to not having encryption at all. I'm not exactly sure why, but it is like an interesting number. To be fair, we're all sort of running KMS today in the V1 flavor, and the memory usage of KMS isn't showing up as like an issue for any of us. It's more of just the scale properties associated with making a gajillion network requests. So I wanted to put these out there and see if anyone had any concerns from just a purely like performance characteristics or any of that stuff. I think, Mike, last time you had said, like we were being a little too synthetic in our benchmarks by like looking at them at like a unit test level. I think this sort of shows that probably no one's going to care. At least that's sort of my gut feeling.
Yeah, that sounds right. That's what I expected. The one thing is the putting the encrypted data in the object, which I think is separate from KDF decision or not. But did you have any further thoughts on that, or whether you want to change that? Because that's a storage format change, I believe.
Yeah, so I didn't have any plans on not using the proto. We did have like an open to do to try to reuse some of the memory buffers. So today we just used like the easiest way of doing proto marshalling, which will create new buffers and stuff, and we don't necessarily need to do that. There is like I forget what it's called. It's like a shared buffer construct that lets you sort of amortize the cost of the proto decodes. So I think we plan on investigating that just as like a nice to have, but like for example, just implementing the KDF based approach was much easier because I had like a proper struct to deal with and not crazy bytes, like just a flat byte array that I'm trying to turn into a struct effectively. So yeah, I wasn't really worried about that as an issue. And if it is an issue, you know, we can make it better by amortizing some of the costs there too.
Okay. Yeah, I did not know that Go Proto had that capability. I thought it always copied byte fields.
I I think it will always do the copy, but like the place where it stores it doesn't have to be constantly reallocated. I think it's the general idea. So it's kind of like a Sig-Auth. So like I think you do have to do the copy, but today you have to do the copy and a new heap allocation to put the copy somewhere. I think that second part is where I think you can optimize. I don't think you can optimize the first part because the initial place that you get the data from is transient. Like you don't own those byte slices. I don't think. I think I'm vaguely is what I'm remembering.
Maybe the proto library doesn't own them, but I think we know that we own those byte slices in our code. So I guess that's the difference. Because what we could do if we really cared is don't copy on don't copy the payload and do an in-place decryption. And I think that would be the optimal.
Oh, I see. So right, like a carefully handwritten deserializer from here's a set of bytes and here's a proto struct.
It wouldn't have to be carefully. I would say we read the proto struct from the prefix. The remainder of the record is encrypted payload, like basically what we did before, but the prefix is more structured and can have more information. I don't know. I would say the ship is sailed as soon as we beta v2. So
right.
Maybe we can. Yeah, I would say maybe we can take it offline. What is our deadline for the code freeze?
Code freeze is July 18th. So less than
July 18th. So plenty of time. All right. Yeah, let's track it for a little bit longer and maybe discuss offline.
Yeah. I think I'm happy to make whatever sort of internal changes, and we can always roll them out over many releases. And if we felt the need to do work over a few releases and just delay GAing, I think that's fine. I don't think that's a big issue. I think if we had to change the gRPC API between the API server and the plugin, I think that ship has royally sailed, and I don't think we can do that without coming up with drastically good reasons.
Yeah, sounds good.
What is on the benchmark results? What's the op in the denominator there? Because it was like 10 seconds per op, some gigabytes per op. Like,
which thing are you looking at here?
I'm looking at the table. So there's 3 rows, and then seconds per op, bytes per op, and so like, what is 19.96 seconds per op? What is the op there?
Oh, the operation is like doing a bunch of creates and deletes of secrets.
Okay, so it's not like one. I was just wondering why it's so high for.
Oh, it's so high because I probably wrote like 10 gigabytes of data to etcd and then deleted it.
All right.
Yeah, so it is a very much a like I had to go update the integration test etcd parameters because I was like running out of space in etcd. And I was like, I'm going to cheat and give myself 8 gigabytes, which is the max apparently that etcd supports.
And so there's one of the other thing I noticed was this aside about bytes per op has 30% overhead with all variations of KMS. Does that mean like once we enable KMS, we are spending 30% more memory somewhere, or?
Right. So basically, if you look at a very narrow picture and you sort of ignore like admission and authentication and authorization and all of those layers, and you're purely like looking at the low level storage of like a Kubernetes secret that's going to get put into etcd and it's of a significant size, and a Kubernetes secret that's going to be put in etcd, but it's got KMS encryption, then yeah, there is a place where you can say you have a 30% overhead.
Okay, but that's just because we have to keep the ciphertext around and the plain text, probably.
And you're still doing all the gRPC of the KMS API and all of those semantics, right? Because or any of that, right? All of that's present, but only if you zoom in far enough. If you step back far enough and you're just kind of looking at it from the outside and all the layers are working, you're down to like barely perceivable mostly, depending on what bit you're looking at.
Okay.
And again, this was only ever looking at secrets, right? So for example, there were like no pods on this API server. There was no actual work being done on this API server.
Yeah. That makes sense. I'm just curious.
Yeah.
All right, next one.
Okay, so the next one. So Mike, I know you had some of the Google crypto folks review our proposed changes for the KDF approach for KMS. The same thing will happen with Microsoft crypto folks sometime next week. And David Eads said that he would also ask Red Hat's crypto folks to look at our proposed stuff to make sure everybody's sort of happy with what we're doing. I don't foresee issues from that, but one thing that I did think of since our last conversation was it was less clear to me now if we were going the KDF approach and every write effectively generated a new deck with the KDF sort of transform with a random info parameter to the KDF function. If there was actually a reason for us to generate a new seed on every API server start. Basically today, in either design for KMS v2, the more you restart your API server, the more decks or seeds or whatever sort of get into the system. So the more network calls you have to do on startup to sort of refill your cache. Now, it's nothing like KMS v1 where you would be in the thousands. You'd probably realistically stay within the hundreds. But like for the current design of KMS v2, we have to definitely generate a new a deck on startup because there's no way for us to persist the counter state in a safe and sane way. That problem, I don't think exists at all with the KDF design. So I was curious if folks thought it would be a good idea to just store the seed in its encrypted form on the API service disk, basically in the exact same way that we do it in etcd. And all the same rotation semantics would still apply. So we would always be asking the plugin, hey, is your key ID still the same, et cetera, et cetera. So like, you know, we would always be sort of following along to whatever the plugin wants us to do. But instead of an API server restart, definitely giving you a new seed, it would only be when the plugin says, hey, my key ID's changed. And then we'd be like, cool, I have to make a new seed and encrypt it with your new key ID and go from there. But it would mean that unless you did a key ID change on your plugin, if you had 3 API servers, basically for the entire lifetime of those servers, you would only have 3 seeds, meaning you'd make 3 network calls on startup of the servers. Or if you had 5 API servers, you do 5. But either way, it'd be like completely negligible and it'd be completely constant for the life of your environment, basically.
Yeah. It seems probably fine. The trying to recall the AES GCM limitations are, I think, dictated by the NIST FIPS guidance, which says that the probability of like a nonce reuse is supposed to be 1/2 to the 32, maybe, I can't remember. So we could, yeah, we are almost certainly fine with the current nonce size. I guess I would maybe defer that to, I don't know, is there any reason to do that now versus later?
So the thought process I had there was, if the sooner we do it, like maybe the sooner we can either require or decide on like the semantics of like whatever storage space we need co-located with the API server, like a file path or whatever on disk. But I was trying to think to myself, like, if you have an API server that is stable and not restarting, and we implement the KDF based approach, right? That internal seed is never going to rotate unless the remote plugin says the key IDs change, right? So if we're okay with that semantic, what is compelling us to say that, hey, on restart, that seed should actually change?
Convenient. It's like where we can share state to subsequent encryption operations, I think. Yeah, I'm trying to think if there are other implications for writing encrypted data to disk, maybe further further constraints that we are unwittingly now beholden to. But I think from just a purely like technical perspective, it's probably fine, although maybe not necessary if we get the speed up that we're looking for with tens of live keys instead of thousands.
Yeah, I mean, David pointed out that, like, if you put it in the etcd, that's like a particular disk, which is a different disk than the API server's disk. Like, conceptually, at least, it might literally be the same disk depending on your deployment strategy, but conceptually they're different disks, which presumably mean they could have different backup strategies and whatever else. I mean, they're both very critical. They both have access to data on disk in a way that's very important.
Yeah, on the similar thought, like, do we have to worry about losing the node? Like, basically, if we stored that encrypted seed on the disk, and let's say we lost that node, then what's our recovery?
Oh, if you don't have it on disk versus if you try to read it on disk and it doesn't work, the nice thing is that it doesn't matter. We would just generate a new seed and then ask the plugin to encrypt it. So it's purely like it can never really hurt you as long as you write the code correctly. Like, so the code would not fail in the cases where it doesn't have it, because on first start, it will never have it. So it sort of has to tolerate that condition no matter what. So recovery is basically just generate a new seed and encrypt it with the remote plugin, or with the plugin, which would encrypt it with the remote KMS.
Mm-hmm.
Yeah, that makes sense.
Yeah. I also don't want to implement this like once this thing is GA. I don't want to like go around and change a bunch of things about a GA feature. Maybe I'm just being too cautious there. I don't know what people think about as what exactly people have in mind when they think of something as GA.
Yeah, I mean, I would You could introduce it with a feature flag. I think it would be fine to have the implementation of a GA API change for the better. Yeah, I guess probably etcd would be the best spot to put it, either like through like an annotation like we do in the control plane controllers, like the endpoints, Kubernetes and Kubernetes service endpoints controller in the API server, something like that.
Oh, I see. So the where we have the master releases and stuff that have like they're stored in etcd, but they don't actually follow like REST semantics. They're just stored in etcd and fetched using those layers. Is that what you mean, Mike?
Well, we have a system for maintaining the Kubernetes service endpoints object.
Mm-hmm.
That is the Kubernetes API server's internal client. Calling just over loopback. I think that would be good. It also means that the encrypted keys are in the same spot as all the other encrypted keys, because the encrypted seed is going to be at the prefix of every one of these encrypted objects. So if we have somebody who has like control on how their backups are, where their backups go, they don't have to think about a new file or a new set of files.
I see. Yeah.
Yeah.
But it would basically be stored in etcd, but not like observable from the Kubernetes REST API. It would be only observable to the API servers through their like low-level etcd connection.
I mean, it doesn't matter. So like the Kubernetes endpoints are available via the REST API.
Yeah, that's fair. I guess I'm more thinking about like if it is available through the REST API in like in the same way like a custom resources, then you have to like make sure that people can't write to it or mess with it, right? Because that doesn't make sense, right? Like it should not be updated by non-API server clients, because it's like it doesn't.
Yeah, but if it does, it doesn't matter though either. Maybe.
I mean, yeah, maybe, right? You're like, yes, it is an authenticated encryption scheme, so we would detect it if you screwed with it. But I don't know if I want to do that. Like, I don't know. I don't know if you would want to make that observable, right? Sort of through the API. I guess is the question. But overall, though, I think your point is though, like if we put it in etcd somewhere somehow, then we don't have to answer the question of, oh, now there's two disks.
Right.
That's fair.
Yeah, I guess we could do something against etcd, the store directly, but that gets pretty gross, I think.
Maybe do it for master releases and stuff.
Do we?
Yeah. So like in the encrypt all test, there is a specific if statement that says that when you encrypt all, make sure you don't encrypt master releases and a few other things, because if you do, you have no way to rotate them, because there's no way to do a storage migration on those because they don't have a REST API.
Okay. Interesting. All right. Yeah, maybe that is an option then, to use the master release model.
Okay. Okay. So I mean,
I'd be fine with introducing this after the beta, and maybe even after the GA.
Yeah. Okay. So yeah, I think my gut's saying, irregardless of if it's part of this KEP or a different KEP, probably a separate feature gate, and that sort of controls the functionality.
Yeah, that sounds good to me.
Okay.
All right. Anything else on that subject?
Nope. I think Jim can have the floor.
All right, Jim, do you want to present?
Sure, I could. Or if you want to pull up the deck, that's fine too.
I'll give it to you.
Your co-host now, Jim. You can take it.
All right. Okay. Yeah, so I don't recall exactly when, but I think it was maybe a month or two ago, we had briefly talked about this. So I think as a lot of folks know, within the policy working group, we've created a API for policy reports as one of the projects we had taken on. And it's fairly widely adopted and used within different, scanners, policy engines. And we'll cover a list of, some of the projects there. But what we wanted to revisit and discuss is what do we do, next with this API? How do we promote it outside of the working group? Because somebody had asked the question, even at one of our KubeCon presentations, that the working group, repo is about prototypes. What's the longer term plan for the API? So wanted to kind of revisit that and see if we could get the, I guess, next steps in terms of potentially proposing this as a SIG API, or if there's other changes or thoughts or feedback that we need to make before we go in that direction. So just few details on the API, and then we can discuss any inputs into this. So the links are in this deck. I won't go into all of the details, but very briefly, the API introduces two top-level objects: a cluster policy report and a policy report, and both of them have a summary and then results. Right, results are more like findings. So the idea is any tool can use these to publish things in a consistent manner that they find. Could be through admission controllers like Gatekeeper and Kyverno, or could be even scanners and other, any other tool that wishes to report something back to the operators or admins of security teams. And we'll talk a little bit about some of the concerns and lessons learned and challenges with this, but the structure is fairly simple. And, like this shows, it's been used. Kyverno uses it, KubeBench uses it, Trivi also has an adapter now. Jaya is also on the call. She can, kind of jump in and talk a little bit about the use in open cluster management, and also within ACM, I think, from Red Hat, right, Jaya?
That's correct.
So yeah, so I think the benefit, of course, here, which is fairly simple but powerful, is that any of these tools can now produce reports, and then external tools can start consuming them in a standard manner. And there are a few examples of that, like both Red Hat ACM, the Nirmata Policy Manager. There's other tools which have mapped these reports now back into OSCAL and compliance formats. So they're providing higher level continuous compliance functionality on top. So that's how this API gets typically consumed. Some of the challenges that we're seeing here are really in, with scaling, and the fact that, of course, if you have, depending on how many policies and resources you have, you could end up with a lot of reports, and keeping reports updated in real time also causes, of course, load on etcd. So we have had some discussions also with Gatekeeper on their, they were looking at adoption, but their concern was mostly around scaling. So that is an open issue. And one of the things we have been talking about is there a way to, kind of offload these API objects from etcd, maybe either through aggregation, or I guess we can't use the same mechanism as events because that's reserved for built-in objects at the moment. But one option would be to potentially with API aggregation. And then the reports do get produced in two different styles from, just across these tools. One is using the report more as a log. and it could be like the last n type of results within the cluster. And the other style is more as a status, right? So adding some information to the report so the consumer knows, is this like the last 1,000, events, or so eBPF tools like things like, Falco will produce events, right? That there's no, it's not a status of all of the findings within the cluster, but it's more of an event log. But other tools like Kirano will produce something which is more of a status for every resource or namespace which the policies are applicable to. So having some information in the report for that, and then just some minor tidying and things like that needs to be done. But those are some of the issues that have come up either from users or in the community. The major one is the scaling, right? So interested in getting any thoughts and feedback on that. And I think there was obviously events is very similar, where there's tons of events that get produced, and that does take a toll on etcd.
Jim, could you maybe, so I had two questions. One, could you describe maybe in a little bit more detail what exactly do you mean by scale issues here for this? Is it just purely like you have just a lot of an object?
Yes, so two concerns. One is a lot of objects that may get created and deleted, or just for policy results itself, right? So one potential way of using a report like this, and Kirano did this in its very early releases, is it would create one instance per violation. And of course, if you have several of these, that could quickly create a lot of objects for that particular type. But the other concern was the sizing also of this data, right? So it can take up a chunk of space in etcd, and because of the 8 GB limitation, that is also a concern.
But this is Jaya. So I think what I would say is typically the way we deal with such scale issues is, we have an offline process that processes this, right, and stores it off in more external storage for longer duration. I think that's kind of the thought process, or that's what I've seen done.
Okay. The other question I had here, do you happen to have like just some YAMLs of these APIs handy that we could just see so I can remember what they look like?
Not right away, but yeah, we could definitely produce some. I'm trying to, yeah, I can share a link on that with some samples. But there is, one of these links goes to, I don't think we have a YAML sample here, but it's the preview of the API itself, which shows what the object structures and things looks like.
Okay. So is your desire to sort of make this a more official like core API?
Yes. So what we were thinking, and and there was some discussions, I think Anusha had with Rita as well, and maybe the idea was to try and propose to make this a SIG level API. So that way, since the working group is not supposed to own code or publish code, and I think what's been done for some of the other, it's not exactly the same, but other projects like, from working groups eventually get promoted somewhere, right? So the question is, what's the best path for this API?
Mike, remind me, when we did the secret CSI driver, did you and Jordan do like an API review on it? I vaguely recall doing something like that.
Yes, we did.
So I assume something like that is warranted here, right? For the sake.
Yeah, we would. That I don't know if this is the case with working group policy, but one attribute of the secret store was that there were like there was motivation to standardize it because we had multiple groups, independent groups building integrations that consumed it. Is that the case with these APIs?
Yeah, so it's more different tools producing the same, of course, the same report in the same format, and then for end users to consume this, or users being, of course, Kubernetes operators, admins, as well as other higher level tools for on the management side.
Yeah, so it started with a KEP, I think. We had a KEP for the API, and then we decided to standardize it, and then we had API reviews, and then that's when we promoted it. So that was the process. I guess this would have to go through the same process and undergo the similar style of review.
So will we need a cap because I guess and that was a question I think we were discussing earlier too, whether it's best to start with a cap, or if it's going to be a SIG API, is there some other process that can be followed for that?
I think a KEP would be good.
The KEP would just make it easier to do the API review because it's a particular structure that sort of lends itself to that anyway, sort of. At least that's my feeling.
Okay.
So, like, I guess, what is your goal by, what is your goal? You want to have a API group namespace under SIG's chaos.io?
Yes, and publish this somewhere, and where we can continue to maintain it in a more sort of, again, for both consumers and producers of this, it becomes more of a supported standard than today. It's in this prototypes repo.
Right. Yeah, so I guess another important part of the KEP, other than just the API view, is the motivations for standardizing, and it would also be useful to demonstrate that this has broad adoption currently.
Okay.
Multiple groups consuming it in its, I guess, unstandardized form.
So I'm trusting your slides, Jim. It seems like it's well on its way, if not already there. So I don't think that's a concern. It's more of writing it down and
right
in a sort of
exactly.
The other thing though, I do want to be just to remind you, once it does make it there, that means any changes to it go through like Kubernetes API review process, right? So in the reverse side of stabilization is changing very hard.
Yeah.
Hopefully you've already figured out all the changes you want to make, or at least a big chunk of them.
Right. It's been fairly stable. We haven't made too many changes other than some cleanup, etc. And we will most likely add in like these other items that I talked about, like the configuration and whether it's a log or a event based report. We can add those in prior to the KEP. But the main other kind of guidance I wanted, and I don't know all the right answers here, but like for the scale concerns, is there, with API aggregation, I think it's possible to then, store in any other etcd instance or any other database, right?
Yeah, with
And-
API aggregation, the sky's your limit. It's basically however much work you're willing to put in, basically.
Okay. And there's no, for the structure of the API, there's no requirements or changes that need to be made if we say API aggregation is the solution for addressing the scaling concerns.
Right. The issue is if you're going to go down the like API aggregation route, how do you tell people to like install the API? And if today they're installing it with CRDs, and then you were to retroactively say, hey, it's going to be an aggregated API, and you install the aggregated API server on there, I forget the ordering. I'm pretty sure the aggregated API wins, I think. So that would be very confusing to a user. Because the CRD could be there, but it's just no longer served by the Kube API server because it sees that there's a conflicting aggregated API service, probably in a higher priority, and then it says, cool, that thing owns it. So from the perspective of the user, it would look like all their data disappeared. So they would have to like remove the aggregated API to get back to the CRD data. So basically, if you want to make that change, make it like before, not like sooner rather than later, because it is kind of like a one-way change.
Okay. So it's not possible for the same API to be either based on the deployment, like different deployments either aggregated or built in, or I guess as a CRD.
Yeah, as far as I understand, the API service object is limited at the group version level, I think. I might be wrong there, but if my memory is correct, that would mean the only way for for the same API to be served by two different entities would be that they're in different versions, but then they would also like not be linked in any way, and it'd be really confusing, right? Because the resource versions wouldn't match. That would be very, very confusing for anyone trying to consume the API. But yeah, so it can get kind of gnarly there. But yes, if you went the aggregated API route, it would certainly allow you to use a different data store that could have, or the same data store but a different schema. The other alternatives, I know like David Eads and others are interested in adding proto support for CRDs. That would almost certainly give you a non-trivial performance benefit over the current JSON encoding that custom resources have. And obviously that would be way less work in your particular implementation, right? It'd be probably a ton of work in the Kube API server to implement the proto support. But if you have time and want to spend your efforts in a particular place, we could all sort of work together on that other shared goal too.
Okay. All right. Yeah. So we'll probably need to think a little bit more about that and see how we want to propose or which direction we want to go in. Because that's the main issue that is, in some ways, that's what at least Gatekeeper is on the fence about adoption because of some of the scaling concerns there. All right. So Mo, you had asked for a sample. I remembered we could produce one through a CLI, so that's what this is showing. Just and this is applying a single policy to a single resource with a Kyverno CLI, but obviously other tools can produce similar policy reports too. It's fairly simple, right? So the main thing is there's results, and results have data like this, which tell you which resource, pass, failed, skip, warn, etc., which policy and rule created that. And then there's a summary at the end, which is just kind of showing the summarized result across all the rules in this report.
Okay. And if it's just to be pedantic for a second, so basically, is it that like you get like 10,000 of these if you run enough tools?
It's possible, right? And especially what we've seen some is if you so like some folks have used this for vulnerability scans, which are noisy. And if you have otherwise like jobs behaving badly, then you see a lot of these produced very quickly, right? So things like that we've encountered.
Yeah, I guess as part of the KEP, there is the production readiness section that deals with a lot of the concerns around upgrades, but also like scale issues and like basically how much data are you creating if you're adding new API objects, how big are they, and all that. So I think those questions will come up, and hopefully David and others might have ideas on how we could sort of move forward. Make those maybe
Okay. All right, so we'll take that on as a next step then, and at least draft up a KEP and kind of put both these topics up for more feedback or discussion, as whether if the feedback is maybe if we go the aggregation route, and we'll just then create that, or before we proceed further with formalizing the API.
If you could just ping me whenever you have that open, and I'll find the right people to add it to the API review project board, so that way we can get someone assigned to it, so that way we can start that process for you guys.
Sounds good. Thank you.
All right. Cool. I will take back over. All right. Micah, you're up.
Yeah, this is mostly just kind of a brief discussion. Just wanted to see get some feedback on an idea. I think I brought up before at one point about the idea of putting like the node name in the projected service account tokens. I think an alternate route that could be really useful, and I can kind of describe the use case, would be optionally adding the requester info in the service account jot. This would be like for not necessarily every token, like the Kubernetes API token, or the token scope to the Kubernetes API server, but for like externally scoped projected jots. The reason really here is that when you have a jot that you want to present to an external service, say in like our use cases, like thinking about using it against an AWS API for authentication, or for a credential exchange, more specifically. We do get information like obviously the service account identity, the cluster via the identity provider, the pod and uniqueness like the pod UID. But it'd be really great to have additional metadata about that pod and specifically where it came from. So like what node it was assigned to. And the requester information would be a way to add that kind of information and additional user extra info from whatever authenticator the node is using, for us to basically have that information embedded in the token. The reason why is when doing, in our case, like a credential exchange with this jot, I would love to be able to do an additional verification that says, or that validates that the service account coming in was assigned to a particular node, and when that request comes in, validate that pod is assigned to the correct node. So in the AWS use case, if we're using the jot, so using like the node's identity, say the node is passing this jot to an AWS service, we can validate that the token, the identity calling AWS, is the same node that's the jot is assigned to. Rather than some, if the token gets stolen and some other identity tries to call a credential exchange API to get credentials. Does that make sense? Does that use case make sense?
Yeah, that makes
I was
sense.
also supposed to add this exact same item to this agenda, and I totally forgot. So
Okay.
you're not the only one who wants it.
Okay, cool. Yeah, like obviously, like we could have, you know, in any kind of credential exchange situation like this, you could do this other lookup of caching pods to nodes or look either cache or look up the pod, you know, UID and service account to the node for that cluster. But that's just like, that's at scale, that can be an expensive lookup. And is just has to be synchronous, right? Or you have to have some cache that you're synchronously updating to get that accurate information. So getting that in the signed token would be just massively beneficial and simplify a lot of things.
Yeah, that makes sense. If it is like modeled like, so I think there's two ways to do it. One is to add a node binding where it would be similar to the, you know, secret and pod bindings that we have today, which might solve your problem. Another way to do it is to model it like a credential origin where we have a list field, and every time we create tokens, we append to the list the requester. Do you have preferences like one way or the other?
I haven't thought too much about it. I mean, again, this is even pre-cap and pre-design. Just thinking about the requirements, it'd be really nice to have a little bit of extra info in addition to the node name potentially. Like in our case, say if you had the user info extras from the authenticator, your authentication module could add additional, you know, key value data that could be that you maybe that you might trust a little bit more than just the username. I guess you kind of trust it all the same. It's just a little bit more metadata you can add and have a little bit more flexibility about adding than if it's like the node binding.
Mm-hmm. Yeah, some of those can get pretty big though.
Yeah.
So there is a token size concern. One of the things I was thinking about though is it's interesting to me that in the Kubernetes audit log, if you're using the system and you impersonate an identity, both the impersonator and the identity they're impersonating show up in the log. But if you use a token request to get a service account token, who performed that action is not like immediately apparent unless that token request was also captured at that instant. So you have to like look at like multiple entries to sort of figure out the whole picture, whereas with impersonation, it's all there. So like one way I thought about something like this could be implemented is if it's not just purely the user extra of the requester that's showing up, but also if there's impersonation happening, that would also technically need to be present, right? Because you could be an actor impersonating a different actor and then performing token requests, right? So like technically there could be 3 identities involved in the whole system. This is assuming we don't ever implement nested impersonation, and then we would have arbitrary levels of any of this insanity. But that was just sort of something I was thinking of. Like you are correct though, Mike, that like I think it's probably groups that's the most concerning, right? Is like if you have 10,000 groups and we try to shove all 10,000 groups into the service account token, now your service account token payload might not even fit into a header anymore.
Yeah,
well,
groups
the user info for nodes might contain not just groups, but like depending on how the platform is set up, it could contain like certificates, it could contain. It depends on how tightly the platform is binding nodes to clusters.
Right. I mean, it can't contain anything that's truly like sensitive though, right? Because it is constantly like.
Can contain sealed sensitive information.
Yeah, it can contain sealed stuff. That's totally fine because it doesn't mean it.
Sealed sensitive information.
Yeah, I mean, sealed stuff is no better than noise as long as you did the sealing right.
Yeah, but I guess it's really big. It can get really big.
Right. So, that is fair. I mean, yeah, I guess I don't know a way around
both. Yeah, same with groups. Yeah.
And there's also already an infinite nesting concern here, I think, like, because you can't impersonate multiple levels through nesting, but you could exchange a token and then use that token to exchange another token for different identities. And if we want that record, then...
the nesting doesn't infinitely go that way because we're not saying that the...
You don't have to propagate if you use one jot to get another jot, you don't have to propagate the original jot's list. Right.
Yeah, we're not saying that it propagates in the user info. We're saying it propagates in the payload. So like the payload sent to like a signer.
Does it not then, do you not just like launder it after you've done the second token exchange? Like you've now dropped any impersonation record or...
Yeah, I mean, I guess it depends on what you're trying to protect against, right? Like today, we don't protect against any of this at all, right? We just say, cool, you can make a token request for that service account token. That's awesome. Here you go.
Yeah.
Fun. Hope you have audit logs enabled for all token requests and an ability to track them really well.
Yeah, like impersonate a node, get a jot, use that jot to do something. It doesn't have the record. Yeah.
But even in that case, if user A requests the jot and then shares it with the user B for whatever reason, you would record the user A being the requester, but you wouldn't know that user B is the one that is actually using the jot, right?
Yeah, that's outside of the scope. Like a sharing credential.
And sharing credentials, I mean, is still possible, right? For example, you know,
yeah.
Your token is in a pod and two users can exec to the same pod.
Yeah, and that's not really like, that's sort of out of scope. We're more thinking like, I think within the context of the API and what the API information the API has.
Mike, when you said that it could be similar to the current pod binding and the current secret binding, what do you mean by that for like node? Like what is the node binding exactly mean here?
So when, so you can, a requester can bind a token to API objects today,
right?
Secrets and pods.
Mm-hmm.
We could make kubelets request a node binding where they bind the token to themselves.
Okay, so that makes sense conceptually in the idea of like, okay, they would request that binding in the token request and they would get it, and on validation for authentication to the Kubernetes API server, we would validate that was the case, and that I guess the node still exists, and I guess the node authorizer would check that.
There's a check that the pod already in the API that the pod still exists. So could the pod couldn't still exist with the node not existing, right?
Yeah, I suppose that's true. At least within the semantics of how Kubernetes works.
It's usually true.
Yeah, I mean, I guess it'd be very strange if those didn't hold together. But I guess at that point, does the binding really mean anything other than to allow someone who's doing the token exchange to, like, I guess when the node does the binding, exactly what information from the node is put into the binding other than the node name?
Node name, node UID. I think it just sounded like a plausible solution to what Micah was looking for, right?
Yeah, I mean, if you put the provider ID and the UID, that'd be probably all I need, but there might be other use cases.
Yeah, I think our use case, like the use case while we were discussing this in GCP was kind of similar to what she was saying, is when we exchange that JOT for another token, we can map the node name, the Kubernetes node name, back to a VM name, and then we want to make sure that like that VM is on the up and up.
Yeah.
So what's the information to here that you guys would need to make this useful?
Node name, basically, or something that can be backed out to the node name.
Okay, so for you guys, node name is within a particular like cluster is unique enough for you to basically trace it back to like the underlying VM and do whatever extra checks you want to do.
I think so.
I'm just
Maybe
asking.
we need a cluster.
Would you want provider ID? I'll spec out provider ID.
What is provider ID in this case?
Whatever the cloud provider sets on the node.
Oh, okay.
It's a
I
spec.
mean, I guess.
It's on the node.
So I think like where this shows up frequently is people wanting to do node authorization on daemon sets that are run on the cluster, and the node authorization is implemented in a third party, I guess a dynamic webhook, validating webhook. And the daemons do not run as like the node identity.
Yeah.
That's where I think it shows up commonly for GKE. And the challenge with those today are they, like everywhere where we have that webhook needs what is it, pod cache, which is kind of expensive.
Yeah, okay. So I guess if we step back for a second, regardless of how we would implement such a feature, is the general idea that we would want to make available at the token exchange point enough metadata in the token itself to allow like an infrastructure provider to make a decision without needing Kubernetes API access. Is that sort of?
Oh man, we're way over. Sorry,
yeah,
everyone.
I know we're way over, and I was like, everyone's dropping. I'm just gonna hang out until Mike notices.
All right. Okay. Well, I'll stop the recording.
It sounds like there's agreement. Thanks.
Feel free to leave. Yeah. I think we have decided that this is useful. Let's figure out how it looks in a KEP, if that's something that you want to drive.